The first of the rules that we're going to look at, and I'm pretty sure we had a bit of a look at it last year, is the chain rule. Now, I get in some ways our chain rule is just saying, well, if we've got a complicated function, y equals, and we want to work out the derivative with respect to x, well, maybe if we introduce another function or variable u to simplify the original function, finding the derivative can be a lot easier, okay? So I think the best way to highlight that is really just to do an example. So let's say, even if we start over here, let's consider the function. Let's consider the function, we'll call it just x squared minus 2x. That's not really much different. Anyway, to the power of 3. So what we're saying, if, for example, we just had the function x to the power of 3, that would be really easy to differentiate, okay? So that's kind of what we're doing. The function inside, okay, it's really the different derivative of the composite function as it says over here. The function inside, if we made that a simple function, say if we put u equal to just some u, okay, and then the original function there, y equals, could be written as, well, we'll replace this term here with u, so that's just the same as saying y is equal to u cubed. Okay, so now we've got two separate functions that are really easy to differentiate. So the derivative of y with respect to u is simply 3u squared, and the derivative of u with respect to x is 2x minus 2. Okay, and then what our chain rule says is that the actual derivative dy dx is the derivative of y with respect to u times the derivative of u with respect to x. Now, dy du is 3u squared times du dx, which is 2x minus 2. So there's my actual derivative, but obviously u is still present, so we've got to change u to be the function that we started with. So let's bring our 2x minus 2 out the front. And then I'm going to have, we'll put the 3 out the front as well. Now I've got u squared, u is equal to that expression. So it's x squared minus 2x to the power of 2. Now the shortcut approach to it, okay, is given if I've got y is equal to x squared minus 2x to the power of 3. dy dx is equal to, pretend that this is just a term, an x term. So differentiate the whole term. So the 3 comes out the front. We multiply x squared minus 2x because that's what it's being raised to a power. We take 1 from the power, which is 2. Then we multiply by the derivative of whatever inside, which in this case is 2x minus 2. Okay, that's what my chain rule is in the shortest form. So if you compare our two answers, they're obviously the same, and I think that's the way in which I'm going to get you to approach it. All right. So let's go to the examples now in the notes. Let's consider this function here to the 5 first. So f dashed of x is equal to 5 comes out the front, and I've got 3x minus x squared, 1 from the power is a 4, times the derivative of inside, which is 3 minus 2x. Now you can rearrange and tidy it up, but that's basically what my derivative is. So now, if I want to work out the derivative at 1, f dashed of 1 is equal to 5 times 3 times 1 minus 1 squared to the power of 4 times 3 minus 2 times 1, which is 5 times, let's see, 3 minus 1 is 2, times 3 minus 2, which is 1. So 2 to the 4 is 4 times 4 is 16. So it's actually equal to 80. So that's what the derivative at x equal to 1 is. All right. Similarly, if I now want to work out f dash of negative 2, I'm going to put negative 2 into that equation. Is given by 5 times 3 times negative 2 minus negative 2 squared times, oops, power of 4 times 3 minus 2 times negative 2, which is equal to 5 times 3 times negative 2 is negative 6. Negative 2 squared is 4, so it's minus 4, all to the power of 4, times negative 2 times negative 2 is positive 4. 3 plus 4 is 7. So that's a big number, isn't it? Is equal to 5 times negative 10 to the power of 4 times 7, which is 35 times 4 zeros, which is 350,000. Okay. Look at part B. Again, the derivative f dash of x is equal to the power at the front. The power comes out the front, doesn't matter if it's positive or negative, so it's equal to negative 3 times, bracket doesn't change, take 1 off the power, negative 3 minus 1 is minus 4, times, in bracket, the derivative of whatever in the bracket is, which is 2x minus 1. Okay, so that's my derivative. And then obviously we just substitute our values in, all right? So we can tidy it up a fraction first if you wish. 2x minus 1 on top with a negative 3 over x squared minus x to the power of 4 on the bottom. All right, so there's my derivative. Let's work it out at x equal to 2. I get f dashed of 2 is equal to negative 3 times 2 times 2 is 4, so 4 minus 1 over 2 squared is 4 minus 2 to the power of 4, which is equal to 4 minus 1 is 3, negative 9 over 4 minus 2 is 2, 2 to the 4 is 16. So negative 9 on 16. It's much easier to evaluate that negative index by bringing it into the denominator. If I now want to work out f dashed of negative 1 equal to exactly the same thing. 2 times negative 1 is negative 2 over, we've got negative 1 squared, which is 1 minus negative 1 to the power of 4, which is negative 2 minus 1. Negative 3 times negative 3 is 9. 2 to the 4 is 16. So one has a gradient of positive 9 on 16, the other has a gradient of negative 9 on 16. All right, so same process. All right, so what about part C? They all look a little bit harder, but the chain rule, it's the best rule to use in terms of our derivatives. F of x equal, let's rewrite it as, what's the actual power? 2x minus 4 to the negative a half. All right, so what's the derivative? Therefore, f dashed of x is equal to, negative half comes out the front, so I get negative a half times the 2 that is there in the bracket is 2x minus 4. I'm going to subtract 1 from the power, so negative a half minus 1 is negative 3 on 2, times the derivative of whatever is in the bracket, so the derivative of 2x minus 4 is simply 2. All right, so let's write f dashed of x equal to 2 times negative a half is negative 1, times 2 is negative 2, negative 2 over 2x minus 4 to the 3 on 2. All right. Now, if I want to substitute 3 into that, so f dashed of 3 is equal to negative 2 over. Now, to the power of 3 on 2 is the square root of number cubed. So I'm going to put 3 into that bracket. So 2 times 3 is 6 minus 4. So I get, that's to the 3 on 2. So 6 minus 4 cubed and then the square root of that. Okay, which is equal to negative 2 over 6 minus 4 is 2. 2 cubed is 8 over the square root of 8. Now, more than likely, we can leave it like that. Root 8 is the same as negative 2 over 2 root 2. So it's negative 1 on root 2, which is quite possibly negative root 2 on 2. Okay? The key is that chain rule. Just differentiate what's outside the bracket, multiply what's by inside the bracket, and then just solve it as we go. All right? Final example. So, first step, let's find f dash of x. I'll go with blue. So again, let's write f of x equals x squared minus 3x plus 4 to the power of a half. So that means f dashed of x is equal to, the half comes out the front, multiplies whatever is in the bracket. Take 1 from the power as we always do with our derivative, then times by whatever's in the bracket, which is 2x minus 3. So simplify that a fraction. We'll keep the 2x minus 3 on top. We've got a half out the front, so let's put that as a 2 there. So if you like, that's the same as having my 1/2. And then I'm going to put the square root of x squared minus 3x plus 4. And the only reason I'm doing that is because I'm now going to substitute some values in. And it normally is a bit easier to evaluate. So f dashed of 2 is given by, is equal to 2 times 2, which is 4. So I get 4 minus 3 in the numerator. 2 times the square root of 2 squared, which is 4. 3 2s are 6 plus 4. So it's equal to 1 over 2 root 2. So if we rationalise, I guess that's the same as root 2 over 4. Okay? Final part, find x if the derivative is equal to a half. All right, now quite possibly it's a calculator active, just depending upon the algebra. So really the setup is the derivative. So 2x minus 3 over 2 times the square root of x squared minus 3x plus 4 has to equal a half. All right, let's get rid of this 2 here, multiply that across. So I'm going to write 2x minus 3 is equal to, over the square root of that, is equal to 1. Let's bring the square root across now. The square root of x squared minus 3x plus 4. Let's square both sides. Gets rid of that square root. So this side squared becomes 4x squared minus 2ab, which is minus 12x plus 9, and that's equal to x squared minus 3x plus 4. Let's get everything to the left-hand side. Subtract x squared, so I get 3x squared plus 3x across makes it minus 9x. Minus 4 across is plus 5 is equal to 0. So I'm hoping that's going to be nicely factored. 5 is just 5 and 1, isn't it? Wouldn't you know it? That doesn't factorise nicely. So since it's messy, boys, I've made an executive decision. Let's use the CAS. Use CAS to solve, and we get x equals the square root of 21 plus 9 over 6. So it's probably not the best example given it's such a messy final answer, but the key skill out of this one, it's really just this first part. I really want you to understand how to use this chain rule. Okay, so that's what we need to practice through these examples.